Visual Studio adds specific support for LINQ to SQL Server data. There's a system.data.link.data context class, which provides a simple-to-use wrapper around one or more SQL Server objects. That is, a layer between you and the data, which makes it real easy for you to work. This creates a hard-coded schema, which is mapped to the original data. Now, when I say hard-coded schema, that means when you create your data context class, at that moment, it sucks in the schema. So if you modify the schema, your data context no longer matches your data. For more robust applications, you might want to investigate the entity framework, and that allows you, it's more complicated, but allows you to create more robust applications that automatically generate the classes that map to the schema. The entity framework provides a real mapping layer between data and objects, but for now, we're looking at LINQ to SQL. And there is a designer in Visual Studio that makes LINQ to SQL easy. Now, if you know your schema isn't going to change, or if your schema is well known, LINQ to SQL works great. To create your data model, add a new item to your project and add a LINQ to SQL classes instance. We're going to try it out using the Northwind sample database. I use Northwind because it's easy and everyone understands it. Let's look at adding a LINQ to SQL class to our project using Northwind. Although my project already contains the Northwind.dbml class, and that is the result of what I'm about to create, let's create a new one from scratch to see what the process feels like. To do that, I'll right-click on the project and choose Add New Item. Here, I'll choose LINQ to SQL Classes and name the thing Demo.dbml. Now we're going to create classes that correspond to classes that already exist in our project, so we won't be able to save or compile this item we're about to add, because we'll get conflicting class names. Now it asks, you're about to add a special file type. Do you want to put this in the app_code folder? And unless you have some special reason not to, you really should. I'll click Yes. This is the design surface for creating our new data context class and the classes it supports. If I go to my Server Explorer, I'll use the tools here to drag and drop onto this designer. Pin that down so it's easier to use. Now, I already have a connection to my Northwind sample database. If you don't, in your situation, you can right-click, choose Add a Connection. Here, name your database. In my case, it's SQL Express. That better be a period or it's not going to work. And down here, from the list of databases, choose Northwind. I already have this, so I'm not going to do it again. You could click OK. I'll click Cancel. Now, from the list here of items in the Northwind database, I'll expand and choose some tables. I could choose any group of tables. I can choose more than one. Categories, I'll Control-click on customers, employees, order details, orders, products, and shippers, say. Now, I want those tables to appear in my classes that I create here, so I'll just drag and drop those onto my design surface. Visual Studio knows how the various tables are related, and so it creates relations for those tables as it creates the design surface. Let me get rid of this. We have a little more room to work with here, and let's zoom this up a little bigger. You can see that there's a table, or at least a class, corresponding to each table, and the names have been changed from plural names to singular names. So this represents a single customer, or in our case, a collection of customer objects. All of these become part of this Northwind data context class. Now we can also set up to call a stored procedure in a very simple way. So from the Server Explorer, if I go down to Stored Procedures, I can drag one or more of these onto the right-hand pane. Say Cust Order Hist. If I drag it over, I see here a method, and that method corresponds to the stored procedure. It will call the stored procedure for me, and it indicates that I pass in a string that is the customer ID as a parameter for that stored procedure. Well, I can't save this demo.dbml or compile it because I've already got all these classes in my own northwind.dbml that I already created. So I'm going to put it away and delete it from my project, and instead examine this one, northwind.dbml. If I open it in the designer, you'll see that it looks pretty much the same. I laid it out using the same tables and the same stored procedure. Well, you've seen the designer. Let's look and see exactly what's in this. To do that, I'll use the View menu and display the Class View pane. In the Class View, I can expand and look at the various classes that are in here. There's Category, Customer, Employee, and so on. Those correspond to the classes or the tables I dragged onto the designer. There's also the Northwind data context here, and if we look at this thing, we'll also find properties down here corresponding to each of those original tables. So we have a property of the Northwind data context class which provides data for us, categories, customers, employees, and so on. Well, let's look at code that works with this Northwind data context. I'll run the project again and click the Query SQL Database button. This takes us into our code, and almost every time when you're working with a data context, as we are here, you want to start by creating an instance of that data context. I've named mine DB, and it is a new instance of the Northwind data context class. Now, working with the Northwind data context class is like working with any other object. We have LINQ over objects, just like we used in the last example. So here, we'll declare our variable products and have it be the results of a query, which is from product, that's our iterator variable, in db.products. Remember that Northwind data context class provides as one of its properties a products property. We only want products where the unit price is greater than 5. We'll order by the category ID and secondarily by product name, and we'll select the product. And we'll then display the results in a grid on the page. Here you can see we have a list of all the products whose unit price is greater than 5, ordered by category ID within category by product name, and down here we get the second category, and so on. I've seen a lot of ways to retrieve data from SQL Server, and this is by far the easiest that I've ever run across. You saw how to drag a stored procedure onto the design surface, but calling them is really easy. The data context class provides a wrapper for each stored procedure that you place on the designer. And it's as simple as calling a built-in method, because they generate a method for each stored procedure that you drag on. Let's try it out. I'll click this button to demonstrate calling a stored procedure. And here in the code, you'll see that all we have to do is create an instance of the Northwind data context class, and here call db.custOrderHist, passing in a parameter that represents a customer ID. So custOrderHist, which was a stored procedure in the original database, just becomes a method of our Northwind data context class. This returns a collection of items, and we'll say, for item in the results of calling that stored procedure, where the item.total is greater than 10, select the item. Or we could get the exact same results using the where extension method on the results of calling that stored procedure. db.custOrderHist, passing cac2, .where, and pass a lambda expression which identifies which items we want to see. Either way, we get all the items from the results of that stored procedure where the total is greater than 10. As you've seen, calling a stored procedure using the Northwind data context class really couldn't be easier. Just as you can use anonymous types with any other kind of LINQ expression, you can use them with SQL, because really all you're doing is link to objects once you create that data context. So the code might look something like this if you want to retrieve not the field named category name, but you want to call it category in your output. In this expression, we have an anonymous type, who knows what it's called, but we're using the product name field and a category output field. Notice that if you don't specify the name for the output field, it uses the name from the input field. We'll have a property named product name and a property named category in the output type from this query. Let's run the demonstration that shows off this behavior. We'll demonstrate how to use anonymous types with SQL Server, and you'll see it's really the same as using anonymous types anywhere else. Here, we'll first create an instance of our Northwind data context class, just like before. And I'd like to now retrieve information from the products table, but only a couple of fields. So we'll say from product in db.products, you've seen that, where product.unit price is greater than 5, order by, category ID, and product name. Now I just want to retrieve two fields, the product name and the category name. Now here I'm specifying product.product name in my new type. Now because I haven't specified a field name, it just uses the name of the original field, which was product name. Category is a new field name, and to get that I'm reaching up from the current product, following the relations back out to the category table that was the parent of this product row, and getting the category name of that category. That's part of the feature that the Northwind data context provided for me. That is the ability to work backwards through the relations to get the parent of the current value and get information about that parent. So we just have these two values, product name and category, in the output of the projection of the original data into a new data type, whose name we don't know and don't care for the most part. If I press F5 to run full speed, we'll see those two fields, product name and category, in the output in this grid view control. And we're seeing only those two fields because those are the only two fields we created in our new anonymous type. The system.data.link.data context class, that is, the base for your data context, allows for data updates as well. It generates methods for performing updates against the data. Now, these updates use implicit transactions. If you want finer control, you can use your own transaction scope around the code you write to perform the updates that allows you to have complete control over the transaction. You call the submit changes method to save your changes. If you don't call submit changes, things aren't saved. Now we're going to use the LINQ single extension method as part of this demonstration. Now the way the single extension method works is it returns a single matching data item. Normally, a query returns a collection of items. I want to be able to work on a single return value, not a collection, and the single method returns a product or a customer or a category or some combination of those. And it raises an exception if the query returns more than one value or zero values. That means if you don't find exactly one result as the result of running this query, you're going to get an exception. And when you're modifying data, that's really what you want. You perform the query, you assume you get one result back. If you don't, you raise an exception and you deal with it. There are other ways to do this. There are other query extension methods that get you the same sort of information without raising an exception, but in this case, it seems like it really is an exception if I want to find a particular row and yet I find 0 or more than 1 rows. Let's try the demonstration which shows off this behavior. I'll click the Modifying SQL Data button so we can go modify some SQL data. Now in this example, we'll make some pending changes and then push them out to the database at the end of the procedure. So, although this isn't directly related to LINQ, it's a useful functionality, and that is the data context class adds support for editing data. So we'll create an instance of that Northwind data context. And here we'll create a new customer, a new instance of the customer class, which was created when we designed that Northwind data context. And we'll set the customer ID, the company name, and then we'll call the InsertOnSubmit method of the customer's class, of the customer's property hanging off of that Northwind data context. The InsertOnSubmit method says insert this new customer at the point at which you make the submission to the database. Right now, we're not. I can prove that because I'm going to now retrieve all the customers where the customer.companyname.contains the letters AAA. And if this had already been submitted, we would see this result. You can't see it now. When I display it on the page, you'll see there's nothing in that list. Now, let's change a contact name. To do that, I'm going to use the single extension method. Why am I using that single extension method? Because in order to work with a customer, I need a single, individual customer object. If I just ask for db.customers, I'll get all the customers. And if I even create a where clause, the where clause returns a list of customers. That's not going to work. I need a single customer. And the single method allows me to pass in a criteria. And if the single method doesn't return a single row, it raises an exception. So I could trap that exception and deal with it. In this case, I know that there is a customer ID CAC2 and I will find that customer. So I don't need to worry about it. But in general, remember, the single method raises an exception if the criteria you specify returns 0 or more than 1 rows. Unless it returns 1 row, it raises an exception. So in this case, it obviously didn't raise an exception, and we're now going to tack an X in front of that contact name just to modify it. We'll come back to that in a moment. Let's now find that existing customer's first order. We can do that by looking at customer.orders 0, gives us the first order. And now we'll find the first item in that order. We'll look at order details hanging off of that selected order, number 0. And we're going to delete it. And the way we delete a row is by calling the deleteOnSubmit method, passing in the thing that we want to delete. We call db.order_details.deleteOnSubmit. The deleteOnSubmit method doesn't delete it now. It only deletes it when you submit the changes. Down here, I'm going to call the submit changes method. It's important you note that this automatically uses an implicit transaction. So if it can't submit all the changes, it won't submit any of them. It rolls back that transaction. Now, if you want to use explicit transaction boundaries, you'll have to do it yourself using the transaction scope class. But for our purposes, this is fine for now. We'll submit those changes, and if any one of them fails, it'll roll back. Submit our changes, and now we'll call that same query again to look for all the customers that contain AAA in the company name. And we'll display the results. And you'll see that we only get the results of the second pass-through. In any case, let's look at the data to see what actually happened. I'll shut down here and go to the Server Explorer, choose Customers, right-click, Show Table Data. And there's the row we added. And I don't want that, so I'll delete it. And also, there is the customer ID who I put an X in front of. There it is. Put that back the way it was. So we've got the data in a pristine state for our next example. In any case, you've seen how you can use the Northwind Data Context class to add, modify, and delete data. In each case, nothing happens till you actually submit the changes.